Hi, I'm Joan Cartan-Hansen. Welcome to our D4K Web Only show. And joining me now to answer your questions about light and color are Kathryn Devine from the College of Idaho and Henry Charlier from Boise State University. Thank you both for being here.
Thanks for having us.
Appreciate it. And joining us in Studio A to provide us with some questions today are students from the Idaho Distance Education Academy. Thanks for being here, guys. Okay, let's go to your questions.
I'm Brooklyn. I'm from Boise. My question is, which is faster, the speed of light or the speed of sound?
So the speed of light is definitely faster than the speed of sound. The speed of light is actually about 1,000,000 times faster than the speed of sound. And one way that you could notice this at home or kind of out in your day-to-day life is if you've ever seen a lightning storm, you'll notice that you see the lightning right away, but it may take a long time for you to hear the thunder. And so that's an example. You see the light from the lightning flash, but because the speed of sound is much slower, it takes a long time for that sound wave to get to you. You can experience this also even at a football game when you're singing the national anthem. You'll notice the sound you hear is out of sync with the singer if you're at a big enough stadium. So the light reaches your eyes almost instantaneously because light is so fast, but the sound takes a long time to get there, and that's because the speed of sound is about 1,000,000 times slower than the speed of light.
Olivia would like to know, why do shadows only reflect black?
So your question is, why are shadows black and not other colors? And the answer to that really has to do with what causes a shadow. I have this is my little wavelength that I brought with me, and this will pretend is light. So if light, normally it will keep going until it hits something. And if I put up my hand, the light hits my hand, and it doesn't go through. And what happens then is, since the light doesn't go through, it blocks the light, and everything on the other side of my hand will not have light on it, and it will show up black. Black is the absence of really all light.
Jack would like to know, why and how does the rainbow form an arc?
So rainbows form from ice or water crystals in the air. And so what those crystals do is they act like little prisms, and the light comes through them and gets bent out. And they bend depending on the length of their wavelength, so the color of the light. And so red light gets a little bit less bent and blue light gets the most bent, and you get it spread out into a rainbow of colors. The reason it looks like an arc is because when you're out looking into the atmosphere, you're looking up kind of on the dome of the sky above you. And so you're seeing the curvature kind of the sky above you and the atmosphere, the particles in the atmosphere. And so the sunlight travels straight through it. It gets bent out into this curve because you're looking up at the sky, which appears curved to you. And then the light bends out into this nice curved rainbow.
Hi, I'm Liberty from Boise. And I was wondering, if you shine a flashlight into the sky, then will it keep going until it hits something, like even if it's in space?
Technically, yes, it could keep going. There's a good chance that your flashlight beam would hit something, though, before it even got off the planet, and that's because Earth's atmosphere is in the way. So there's a lot of dust and gas between the surface of the Earth and outer space. And so the light waves would probably get scattered out before they got to the top of Earth's atmosphere. But let's say you were able to get some of those photons or those pieces of light from your flashlight got out to space. Then technically they would keep going. One of the tricky parts, though, is that it would be, as you get further away from something in space, it gets very, very faint. That's why our sun is bright and other stars are faint. And so I'm not sure anybody from another planet would be able to actually see your flashlight, but they might get a photon or two from your flashlight.
Nikki would like to know, why do some animals see only black and white when we see color?
Well, I am not so sure that some animals only see black and white. I think animals see different levels of color. Some see less color, some see more color, and the reason for that has to do with the amount of the makeup of the eye. The eye is made up of cones and rods. Those are types of cells in your eye, and some animals will have more cones than rods, and some will have more rods than cones. Animals, for instance, that are awake during the night, that hunt during the night, they won't have as much need for color. They'll need to be really good at seeing contrast and being able to see dark and darker and lighter kind of objects when they hunt, and so they'll tend to have more rods than cones in their eyes. So if if then they wake up during the day, they may not see color as well, but it doesn't mean necessarily that they only see in black and white. I'm not sure if there are animals that only see in black and white.
Jace would like to know, why do light waves travel faster than sound waves?
So sound waves move very differently than light waves. They have actually completely different underlying physics as for how they travel. Sound waves travel because the air, let's say you're talking in a room filled with air, the actual molecules in the air compress together and carry that sound wave through the air to somebody else's ear. And so you have to wait for each molecule to kind of communicate the wave to the next one. Light waves, on the other hand, don't need to communicate through air. They travel through what's called electromagnetic radiation, and they're a propagating field. And they don't need to wait for molecules to compress to travel, so they can just go straight on through, which is a much faster means of travel.
My name is David, and I live in Meridian. How do neon signs work?
So neon signs are tubes filled with neon gas, essentially, and you're running a charge through them. And so in gas, the building blocks of gas are atoms, right? And so neon gas is pure neon, just a bunch of neon atoms. And what you do is you take the electrons in the neon gas and you're bumping them up to a more excited energy level. And it turns out that in molecules, you've got electrons that can only exist in certain levels. And so what happens is called an emission line. The neon, so we run a charge, we plug it in and turn it on, and we run an electric charge across the tube. And that excites all the electrons up to a higher energy level. And then they jump down, but they can only jump down in kind of quantized energy levels. That's just the way atoms work. And so it turns out with neon gas, most of the jumps they can make give off yellow or orange light, which is why neon light looks yellow or orange to us. With argon is another one. So if you've ever seen a neon sign that looks like whitish blue, that's actually got a different type of gas in it that emits more in the blues and kind of greens, and you see more of the blue colors from that type of emission line.
Actually, even pretty much any light works that way. When you have a light bulb, or whether it's fluorescent or neon or incandescent, like where you have a tungsten filament, it's all about exciting those electrons into a greater excited state. And then I always think of it this way. I like to be low energy whenever possible. I just, exercise is good, I know, but then I get tired. So my body always winds up in a nice relaxed place. So I get rid of a lot of energy by sitting or sleeping. And molecules are kind of that way too. When they get in the really excited state, they like to drop their energy, get rid of their energy somehow so they can get to a nice, stable, low energy state. And to do that, as you mentioned, they give off energy, and sometimes that energy is emitted as light. And so in the case of an incandescent light bulb, like one that you normally have in your house, you have tungsten, which is a filament, and you put electricity through that filament, and that excites those tungsten molecules, the electrons into the excited state, and then when they return back down to their ground state, that's what we call the resting state, it gives off light, and that's what we use. So I guess most lights probably work that way.
Mm-hmm.
I'm sorry, but we've run out of time. Thanks to Kathryn and Henry. I appreciate you both joining us.
Thanks for having us.
Yes.
And thanks, too, to the students from the Idaho Distant Education Academy. Thank you, guys. If you want to learn more about light and color, check out the D4K website. You'll find facts, links, games, our light and color broadcast show, and lots more. And every week, check out my blog for the latest science news for kids. Thanks for joining us on this D4K Web Only.